So up next we have Angela, a cybersecurity consultant and a former security subject matter expert at Microsoft, who now leads the development of technical training content for other cybersecurity professionals, with her talk, Recent IoT Breaches and What They Reveal.
Hi everyone, thanks for joining me. So in this session I will cover IoT security. I'm sure you all know what IoT is, so I'm not going to spend too much time on that, so I'll go straight to, I'll cover first what makes IoT devices vulnerable. I will then walk through 3 recent real attacks. Then I'll show you a very quick demo on how attackers can discover vulnerable IoT devices. And then I'll finish off with some practical steps that you can take to design secure IoT applications. So let's look at why IoT devices are vulnerable. So first of all, as we can see, they tend to use weak credentials. So this is because often these type of devices, they ship with weak or unchangeable login details. So sometimes you can't even change the login details, and sometimes they even use hard-coded credentials. This is really one of the main reasons why they are vulnerable, but there are other reasons, as we can see here. So firmware issues and lack of vendor support, these are connected because, of course, these type of devices, especially if they are low cost or if they are discontinued, they tend to have poor vendor support, which means that if there's no vendor support, then there's no security updates available, or if there are security updates, they could be delayed. So many of the devices have vulnerabilities that have available updates, but they're just not installed. The following one is actually vulnerable web interfaces and coding errors. These are very, very common to all applications, really, so not just IoT application. So I'll move quickly through the next one. The next one is clear text protocol. This one is very important because some IoT devices tend to use unencrypted protocols, and we all know that that means that communication, when it's sent to the clear, it can be easily intercepted, so that's very important. But it's important to understand why they tend to not use strong encryption. So the main reason for this is that these devices, because they're smaller, they tend to have very limited CPU and limited memory and storage, which means that it's very difficult to configure strong security features such as encryption. Encryption specifically is very computationally intensive, but also other features like threat detection, for example, is very difficult to install even a simple anti-malware on a small device. So this is a very important one, but we will see later that there are actually some encryption algorithms that are suitable for IoT devices, so I'll mention those later. When it comes to DDoS attacks, so these type of IoT devices, they can be either the subject themselves of a denial of service attack, or they could also be hijacked and participate in a larger scale denial of service attack. So basically, they could easily become bots in a botnet. Then we have pre-installed malware. So with pre-installed malware, we're referring to how IoT devices can be vulnerable through the entire supply chain. And there has been recent cases, I'm going to cover one next, recent cases where malware has been installed on quite a lot actually, of IoT devices during manufacturing, so before being sold. So bad box 2. So this is a very recent attack where malware was installed on devices before being sold. So this was a major one. So in this attack, over 10 million devices were infected with pre-installed malware. So this type of malware was a firmware level backdoor. Some of these devices were, for example, TV boxes, photo frames, projectors, or even tablets. They were manufactured in China. And these attacks, they weren't actually sold, many of them in Europe. It mostly affected North America and Asia. But this attack was so severe that the FBI even issued a public alert, and this just happened a few months ago. So what's concerning about this attack is that it highlights how the supply chain can be easily compromised, and it highlights how attackers are shifting left. The next attack we're going to talk about is the Mars Hydro data leak. This is also a very recent attack. So the exposed data from this attack, it came from smart grow lights, which are devices used in indoor agriculture. So the type of data that was exposed included Wi-Fi password, IPs, device IDs, and even API tokens. So you can imagine what attackers could do with this type of data. They could easily infiltrate networks and even pivot to other systems. So this was a major attack. But what makes this attack really interesting is that the manufacturer actually indicated in their privacy policy that they didn't collect this type of data. And this is really important because, well, there are, first of all, expensive fines for organizations that don't inform the users of the data that they collect. So when we see these type of attacks in the news, there are two main questions that I think we should ask ourselves. So first of all, was the data encrypted? Because, of course, if it was encrypted, then this attack probably would have never happened. But even more importantly, was the data that was collected necessary? Because the main defense against data breaches is not collecting the data in the first place. So unless really necessary, and especially if you're dealing with IoT devices, sensitive data should never be collected because IoT devices, as we saw earlier, they are inherently insecure. So data minimization is extremely important. The last attack we're looking at is a healthcare ransomware. This is from last year. So in this attack, some US hospitals were hit by ransomware. They're targeting medical devices. Some of them were infusion pumps or MRI scanners. So these type of devices are often connected to hospital networks for monitoring and control. As a result of this, as you can imagine, patient care was disrupted. So operations, appointments were canceled or delayed. So you can imagine the type of consequences for these type of attacks. So why this attack happened? So there's two main reasons. So the first one is that attackers exploited outdated firmware. So that means that the firmware had vulnerabilities that were not unpatched. So it's likely that there were some patches available for that vulnerabilities, but they were probably just never implemented. And we saw earlier how it's very common for IoT devices to have unpatched vulnerabilities. So this is actually a very common cause for cyber attacks. The second cause was also because these devices were not segmented. They were not isolated from critical devices. So poor network segmentation. So segmenting networks is really important because it dramatically reduced the blast radius. So with blast radius, we're referring to basically how far the effect of an attack can go. If a vulnerable device is compromised, but it's isolated, then it's very difficult for an attacker to really do anything else and pivot to other networks. They can still do it, but it's just a lot harder. So next, I'm going to show you something you might find a little bit scary. So I'm going to show you how easy it is to find vulnerable IoT devices. So by the end of this session, you may decide to throw away all your smart devices. And so this is Shodan. Shodan is a website, shodan.io. It's a publicly available website, so anyone can use it. This is used to search. It's basically a search engine of internet-connected devices. So it can be used by attacker, but by anyone really to search and find IoT devices or devices connected to the internet. So looking for vulnerable devices is the main step that attackers take. So it's called reconnaissance in the cyber kill chain, is really what allows them to even start an attack in the first place. So let's say that I'm an attacker and I'm looking for vulnerable webcams. I could just type webcam in the search bar. I click search, and this is an example of the results that I've find. So I masked some sensitive data, so hopefully you won't try to hack into these devices. But as you can see here, so I can see a list of webcams. I'm only showing you the top two, and you can see that one of them is labeled honeypot, which means that it's probably just there just to lure attackers, so it's probably nothing too sensitive about that. Let's hope so. If I select one of these, so if I select, let's say, the first webcam, here you can see there is a list of open ports, so you can imagine how important that is. Again, I masked some of the sensitive information, so you won't be able to see the IP address, but you could if you went on this website. As you can see, port 23 is open, so what that means is that I could try to use Telnet to connect remotely, and if the device is using default login details, which is often the case, then I could probably just try to guess it and connect remotely. And if this is not enough, I could even scroll down from the same device and see the list of all the vulnerabilities, or at least the one detected in that webcam. So I'm just showing you the top 3, but you can imagine how valuable this type of information is for an attacker, because if I know what vulnerabilities are in that device, then I can prepare my attack, and I know exactly what to look for. So that's pretty scary. So what can you do as a developer? So I know this session was very short, but I hope you found some valuable information. So as a developer, the first thing you could do, in addition to the most basic thing like secure coding and avoiding hard-coded credentials, these are very basic, but in addition to these, design with privacy in mind, so minimize as much as possible the information that is collected and processed by IoT devices, because even if you have everything in place, even if you have encryption and everything, data minimization is still probably one of the most important things you can do. Enforce MFA. So the word enforce is very important here, because if you just enable MFA but you don't enforce it, we all know that most users won't bother implementing multi-factor authentication. We just know that. So the best thing is to actually enforce multiple factor authentication. When it comes to encryption protocol, so we've seen earlier how difficult it is to configure encryption on an IoT device, but there are some encryption protocols that you can use. For example, TLS 1.3 is the latest version of TLS, so that's for encrypting data in transit. TLS 1.3 is a lot less computationally intensive than the previous version 1.2, so that's a good one. When it comes to data rest, then we have advanced encryption standards, which is very common, it's very strong, but it's not the most computationally effective. So a common algorithm, an alternative would be ECC, which is elliptic curve cryptography. Lastly, provide clear documentation and ensure secure default configuration. So clear documentation is important because it allows users to understand what security feature can enable, but also what features are available, so they can decide whether to turn them off or not, because turning unused features greatly reduces the attack surface, so that's very important. But also ensure secure default configurations, because even with the best documentation, we all know that most users probably won't even bother reading that, so just ensure that the devices that you develop and the application you develop are secure by default. That's really the best defense. So that's the end of it. I know it was a very short session, but I'm hoping that the key things you'll take away from this session is that IoT devices come with risks that we can't ignore. So if you're developing them, you need to really think about security and embed it from design to deployment. And it's also important to look at past and current cyber attacks and learn from them. So all these help us build safer IoT systems. So thanks for listening, and hope you enjoyed the rest of the event.
Thank you very much. If there's any questions, I can pass the microphone around.
As long as they're not difficult questions.
So obviously IoT devices are like a real hotspot for exploitation at the minute, but a lot of the issues that you're talking about and they seem to be encountering were very common in like network devices and stuff in like the 2000s. Do you think that like since IoT is like a newer industry and like especially like medical IoT and stuff like that it's so recent that they're essentially just replaying the same mistakes that were made about 20 years ago?
Exactly, and most of these attacks happen just because of things that that most people should really know, but because companies like hospitals, they have a very low budget, and they probably don't even have security professionals, they probably can't afford to hire a security professional, they're vulnerable to really the most basic type of attacks. And if every company, really every business is vulnerable to basic attacks, we should really invest more in really cybersecurity professionals and increase the knowledge of common and well-known attacks.
Yeah, I have a question about the IoT malware. Obviously, it's one thing when you have control of the supply chain, but then it's another case when you can really only communicate with the vulnerable device remotely. But when it comes to IoT, I don't know if this is correct, but my impression was that it has some firmware that's in a read-only state, and it's not like a proper computer where you could install something new. But is that actually the case? Like, how does it work for IoT malware? Does it?
Yeah, so most IoT devices, I'm not really an expert on this specific area, but most IoT devices use very outdated operating system, for example, Raspberry Pi, so these are just very updated. There are other operating systems that are also common, but the one that I'm most aware is the Raspberry Pi IP. So it's just they're very outdated operating systems, so that's the main reason why they're vulnerable.
Could you potentially say that one of these ways to ensure that they're protected is maybe to lock down the system even more? So
Yeah, that's actually one thing that many companies are trying to do. It's not very common, but I have seen that. So there's also some type of certificates you can take that companies release to confirm that their device, the hardware of their device, have been locked and in a secure state. I don't think it's that common yet, but it is becoming more used.
All right, fab. Thank you.
Thank you.